Hello. It's a pleasure to be here second time, and just for a wee second I wanted to say that we're all grateful, and I think I'm speaking on behalf of everyone, once again, that people, even on Saturday we were just talking to Yuri Shtarov, whether trying to predict whether there would be people in the audience, and it's great to see that there are people in the audience. It's not great, however, that I'm not a specialist in either phonological typicality or dyslexia. So those who are professional dyslexia students, please forgive me that our story will be quite simplistic. And I readily admit that I know very little about dyslexia, and the mechanisms that we sort of are talking about are probably oversimplified. But so was this guy, and he was president for 8 years, so it's fine. I think we will just have to figure it out as we go. Moreover, if I don't know what to say about either dyslexia, you talk to this guy, is right there. And if I don't know what to say about phonological typicality, you talk to this guy, who's not here, which is a problem. But he will be here, so just keep it until he arrives. It is also important for me to make one more caveat here. It is about phonological typicality, this talk. It's not about dyslexia. We're using dyslexic readers because they provide a useful test bed for specific parameters of phonological typicality, or specific mapping from orthography to phonology, and the emergence of phonological typicality effect. And it's a preliminary data. We only have a first pilot database that I will talk about this slightly later. What phonological typicality is, according to Tom Farmer, is the degree to which the sound properties of an individual word are typical of other words in the same class. And in his experiments, and in this experiment, he uses a very useful notation. He calls them nouny nouns and verby verbs, verby nouns and nouny verbs. So that's how congruency in this folk sort of terminology is encoded. So nouny nouns are congruent nouns, the nouns that have phonology congruent with their class. So they are nouns that sound like nouns. Verby verbs are verbs that sound like verbs, and there are incongruent conditions, or incongruent words. Well, how do we know that? Again, the original study from, that's published in PNAS by Farmer and colleagues measured this phonological typicality by using cluster analysis in corpus data, in large English language corpus. And they identified specific phonemic features during to which they managed to finally arrive at clusters where you can identify congruent noun-like nouns. And here's the example, a word like marble, or verb-like nouns. The noun such as insect. And we are going to be using only nouns in this experiment, although in his original study and the studies that followed, he used both verb materials and noun materials.
I have trouble formulating my question, but I'll start right there. Your critical area is the word coda. So if we think of people literally activating their phonological code, they would probably start from the beginning of the word. So number one, I certainly I'm aware of this tight graphemic to phonological recoding issue in dyslexic people. But in this particular case, I'm wondering whether the crucial point is that they do or do not activate the phonological code, because the disambiguating or the critical information is at the end of the word. So if we believe in the cohort theory, depending on where you are with your theory of reading, and I admit that coarse-grained reading would probably zoom in on this ending part, closing part of the word. However, this is not about graphic phonological recoding. This is, as you say, about class typicality. So my question is basically, do you think they read the word first, and then post-lexically somehow they incorrectly attribute it to the wrong class, and this slows them down? Or, what comes first? Or they just zoom in on the inflection, on this critical part. They think, oh, that's the verb. before they actually access the lexical meaning, and that's how they get it, they slow down?
That's a very good question, and actually, the at least three parts. While I was listening, I was trying to keep in mind three important things. So, in this data set, we did not analyze the landing position, so we don't know where they land. Well, we can extract that, but I don't have this data. And they tend to land to the left rather than to the right of optimal viewing point, correct? Correct. So if anything, they tend to land earlier, not later. Then also, what I think is very important to look at, if it is the prediction type account, then it's possible that the effect can actually arise at the verb, because that's what generates the prediction. So you read the boy collected and you expect the noun class, not the verb class, to come into that. So I wouldn't be surprised if the effect actually emerges earlier. And it's also possible that they do post-fixation lexical processing. That's why fixations themselves are not capable of showing that effect. It's very, very interesting. Accuracy rates are pretty high, so we know the process fine. But I don't know, it's an interesting hypothesis actually. But I don't know how to test for it.
The line of the left, as you say,
Yes.
and the information is on the right. So by the time they get to the right,
Okay.
they have already accessed the word.
Yeah, how do we know that the information is on the right though? I mean,
What is their
correct. But that's just one item. I don't have the full set of items. I'm sure that, well, these are typical items that Tom has been using in his papers. But I can assure you that they are quite heterogeneous in terms of how you could read them. You know, like Andriy tried the same trick with insect that would sound more verby. I actually tried the same rule of thumb approach when I looked at these items, and many people do, because Tom gets criticized for this. You know, what is this thing? Is this because there's some sort of, they sound like verbs? What does it mean? Is it insect? Like insert and stuff, you know? No, they're actually quite heterogeneous, those items. So there's something on top of the obvious that makes them verby.
In fact, I'd like to continue with this very issue, because one of the theories of dyslexia is that it is a slight form of the unilateral neglect, in which you don't get the first part of the word, but you get only the last part of the word. So maybe the assessment of the word typicality should be a little bit different for dyslexics as compared to normal people, because, well, for example, yeah, if you get this RBLE, this might be difficult for a verb rather than for a noun as compared to MR.
Yeah, so it's a
AR, yeah.
question, isn't it?
Exactly, yeah, so that's probably, I don't know, maybe a sort of a neural network model might work out something like this.
Well, simple answer is that's why we have the new study. And that's why we want to control for perceptual, phonological processes and prediction generation processes. I actually advocate the most parsimonious account, the most simple account, I shouldn't say parsimonious, simple account, partially because I come from cognitive psychological background, right? So I think it's just, the channel is small, the resources are limited, and they spend so much effort trying to perceive properly the perceptual form that they just don't have capacity to accommodate for something as subtle as phonological typicality. So phonological typicality is not everything in the word, right? It's probably the minimal thing, like affordances or embodiment for that matter. It's not that everything that's the main thing that carries the meaning. So I just think they're insensitive to it because they don't have capacity to be sensitive. And regular readers have a bigger channel, more resources, that's why they're sensitive. But it's a good question. That's why we're doing the next thing.
Please, can you give some examples of skip errors of dyslexics? They skip what kind of stimuli? This first question. And the second is, what do you think about level theory, about prediction according to first syllable? Frequent or infrequent? This is another kind of predictions, not phonological typicality, but according to how many words start from some syllable.
The second question is easy because, again, I would need to have the full set of of items in front of me to be able to answer it. And also, I would need to know whether the syllabic structure, how frequent each syllable is with regard to those words. And I simply cannot remember that. And that's a good point.
Not in the your stimuli, I mean syllabary, mental syllabary according to level theory. In our mind, we have some more frequent words according to first syllable and another.
Oh, is your question what I think about the theory or how our items...
Did you take into account this factor, this variable
Yes. We
in
don't
the
take
prediction?
into account thus far, but that's a very important factor, I'm sure, and it can explain part of the variance, possibly. But I don't know, because we didn't control for that matter.
And some examples of
Skips, correct. Well, of course, we only analyze target words, so if it's a skip, that means that it didn't fixate it. That's the example, that's a typical example of skips. I didn't look at other words in the sentence because at this point we're only interested in the target word. But like I said, it's probably important to look at the verb as well because that's where prediction is generated supposedly. What they usually skip, I mentioned this before, that's what Paul tells me. What they usually skip is what we don't skip, what regular readers don't skip. That is the notional words, right? The regular readers, non-dyslexic readers, tend to skip functional words. And the reason why dyslexic readers skip notional words is because they're too hard for them and they just give up on trying to read. So that's the puzzling part of the data right now. But you have to bear in mind that we're only doing this is just pilot, right? If the story stands, then we will need to conjure up some explanation. At this point, we don't speculate.
Okay, so we should probably stop now. We are running out of time. So all the other questions will be left for the break.
Thank you.
And now I'm happy to introduce Alexander Nikolaev with his talk, Behavioral Effects of Number of STEM Allomorphs on Word Recognition.
Now, so you don't see all of yeah. Okay.
It's just imperfect,
Yeah, okay, good. So, first of all, I would like to thank organizers of this conference, and I'm glad to be here. So, here we see examples of monomorphemic words versus polymorphemic words, like a child, which is monomorphemic, and childhood and childcare. Childhood is derived words, and childcare is a compound. So, according to processing models that involve parsing or decomposition of complex words, this requires additional processes, and as a result, we have slower reaction times in tasks such as lexical decision for complex words. But there is some studies that argue that actually in some cases polymorphemic words, complex words, can be processed faster than monomorphemic words. For example, when we have derived words with productive suffixes or compounds which are transparent. So, according to, for example, the race model, which is a dual root architecture model with parallel processing temporal dynamics, those words can be recognized faster than, complex words can be recognized faster than monomorphemic words. And explanation for this is probability summation or statistical facilitation, which in essence means that the reaction time in a given trial reflects the processing time of the root that happens to be the fastest on that trial. So, however, the crucial challenges for the race model are strings that are polymorphemic strings that are formally fusional, right? Like in words food, feed. So, does this model predict faster activation of the word food if we see word food, or does not? And I guess that the race model is not the best model for prediction this kind of words, because we cannot expect decomposition when we see words like food, because it's morphologically simple words. So if we compare to words table, which just doesn't have allomorphs, like allomorph table, and words food with two allomorphs, then should we expect some facilitation of word allomorphs, or maybe there is some inhibitory effect because of variation of the forms but no variation of meanings? So, and I guess we can expect some activation of this food and feed allomorphs if we adopt this lemma terminology of Lefeld at the lemma level, abstract level of word decomposition. And do we have some evidence of benefits of such decomposition of possible allomorphs? So we do have, there are studies that argue that the greater involvement of irregular words with other parts of grammar facilitates the memory processes associated with irregular forms, and studies that argue that semantic factors such as morphological family can facilitate processing, and complexity of the inflectional paradigms is also one of the facilitating factors. And studies that argue that in our mental lexicon, words with more complex and informationally rich paradigms have more links to other words. So we have evidence